Hi everyone, welcome to YPRL. My name is Karen. Pleased for you to join us. I'm here to introduce Kailash Kalidoss, who is a NASA Solar System Ambassador, and we're really excited to have this special opportunity to connect with him. He's speaking to us directly from the Bay Area in California. So welcome, Kailash.
Thank you so much. Thank you so much, Karen, for this opportunity. And I'm very excited that I can take this NASA Solar System Ambassador role to other countries, especially Australia. And YPRL, thanks to YPRL, actually, to give that opportunity to me as well.
It's hard to describe how exciting this is when you first contacted us, especially because NASA is very glamorous and so far away. It's almost like you have to pinch yourself when you get an email from NASA. It's like, is this for real? So we're very, very excited to be able to for you to join us. And in our community, we have a lot of young people who love space. So we're hoping that they'll be excited too.
Likewise, Karen. So to give a brief introduction about me, my name is Kailash Kalidoss. I'm a NASA Solar System Ambassador. I became a solar system ambassador in the start of this year in 2020. My role is to take aerospace education and NASA missions information about them to the community, both in the US as well as the rest of the world. So that's briefly my role. I'm not an employee of NASA or anything. I'm just volunteering. I'm called a Solar System Ambassador, and this is a program that runs in the US.
Okay, and I think we've connected with you at a good time because today you're presenting about the Mars mission, which I didn't know much about before, but I realized it's actually planned to launch really soon.
That is really correct. So this week at NASA is going to be really exciting because first we have this manned mission from the US to the International Space Station using the SpaceX system. That's going to get launched on May the 27th. And following that, the next big event is the launch of the Mars rover in July. So I thought that would be a pretty relevant topic for us to discuss today.
Yeah, and in fact, since I announced this event, I've received some communication from some school children in our community who said they're actually learning about space and about the sun at school. So they're hoping to be able to tune in and get some extra and rich information directly from NASA. So.
Yeah. So yeah, I get to talk to a lot of people in NASA either virtually or I've even met a couple of astronauts in an event and been to an event at a NASA base. So I do interact with these people on a limited scale. As I said, I'm not an employee, so I have an interaction system that's there as a part of the SSA program, and I also represent Civil Air Patrol, so I'll let you know the details about that later in this meeting, but that's also another platform for me to meet these guys.
Mm-hmm. Sounds great. So are you ready to start your presentation?
Sure, absolutely. So let's go ahead and start. I'll just pull up the slides for you. It should be up.
Oh.
Moment. Go ahead and present it. If you're able to see my screen.
Yes.
Should I share my screen or?
Yes, I think that would be best.
Yeah.
Yep. And your screen will, the whole image then will be off your PowerPoint
right.
Because you can share the PowerPoint window itself.
So I'm just going to share my screen and share the PowerPoint window. All right. So.
Yep, I can see your PowerPoint.
Right. I'm just going to present it at the moment.
Yep. Go. Beautiful.
And I would say put it in full screen. Hide presenter view. Okay. I think this is the view we are looking for.
Yep. Got it.
So let's go ahead. And this was actually given by I'm taking most of the materials from the Jet Propulsion Laboratory, and there's a gentleman called Kenneth Wilford who had presented the rover mission to us basically. So I have given him credit because I've been using some of his material in my presentation. So let's begin. This is the first slide. So this is the image of Mars. As we know, Mars is also called the red planet. This is the typical view of Mars you get from Earth on a good day, on a good clear day, when you don't have any telescopes or anything. If you're lucky, you can spot it of this size. If you do have a telescope, that image actually is getting a little bit bigger, but it's also blurry. At the same point, we don't a normal telescope that's available off the shelf is like able to get you to this level of magnification, but still doesn't convey anything great. But the exploration of Mars just began like way ago in 1886. So there was this gentleman called Giovanni Scarpelli who actually came up with a map of Martian landscape. And he said that there may be a possibility of streams of water on Mars. So this is the landscape that he proposed. So why I'm telling you all this information is because like I wanted to give an intro on the history on which the Mars exploration has been done so far. So it's going back to 1886. So this gentleman from Italy came up with this image. And he also said there may be water on Mars, and that's the quote here. So it may spread to a width of 100 to 200 kilometers or maybe more. But this is just his prediction. This is not reality. So in 1909, there was also a newspaper article by Lillian, which says there would be life on planet Mars, but those were again predictions because we couldn't actually see anything pretty close. And then in 1965, we had the first kind of mission where from the orbiter called Mariner in 1965, which gave the first glimpses of Mars to us. But those images were pretty raw, and we couldn't make much of it either, so we couldn't answer any of the questions. Back in 1975, the Venera 9 went the other way. This is a Russian spacecraft orbiter, which actually went to Venus and checked whether Venus is even close to habitation or not. But they discovered that the surface of Venus is highly acidic, and their spacecraft lasted a few minutes, and it gave these images. The first formal Mars exploration began with the Viking mission in 1975. So using the Viking mission, the Viking orbiter gave some significant images, like I'm going to show you now. And it also had a lander, which showed the surface of the Martian landscape as well. But here came the disappointment. So all the earlier predictions were pretty much wrong. So there were no visible signs of water on Mars. Also, there was no kind of life form on Mars. But our conquest to learn more about Mars kept us going. In 1997, we had the Pathfinder rover delivered by NASA to actually answer our questions regarding the origins of Mars and the suitability of life going forward. In 2004, we sent another rover called Spirit and Opportunities. There are two different rovers sent to Mars on two different locations. Basically, the idea is to see the origins of Mars. So we now know that there is no life as such on Mars, and we cannot live as is on Mars. So we have to create a life support system. For that, we have to learn how best we can use the Martian environment to actually develop systems that can sustain life in the future. And in 2012, this is the latest rover that's there. It's called Curiosity rover, and this is the rover that's collecting most of the information right now. So to give a history of Mars missions, there are two kinds of systems here. One is an orbiter that you can see, like which circles the planet around the planet and tries to get data from the top, and then you have the rover itself, where you have an actual landing on the surface of the planet, and the samples are collected at that point of time and to get data. So the agenda has been to follow the water. That's the most common way for us. So if we come to know regarding the origins of water on planet Mars, there was a state in Mars where there was water. So there is evidence of that, but water is not in liquid form anymore. So once we trace the origins, we can try to explore the habitability and seek signs of life. So that's the whole idea. So if you see, we are moving from the left side of the screen to the right side of the screen. And the ultimate goal will be to prepare future human explorers through these missions. So right now we are in the M2020 rover, which is right there in the 2020 column. So we are seeking signs of life. This is the main purpose of mission of Mars 2020 rover. So although we are launching this system in 2020, it's anticipated to land in Mars in 2021, and we have named the rover as Perseverance. This happened very recently. We had a naming ceremony, and then I think an educational institution was privileged enough to actually name it, and a student was his entry one, so hence the name Perseverance. So to give a brief overview, this is going to be a launch system that's going to take place using the Atlas 541 launch vehicle. So July 2020 is the readiness date. We don't have any kind of postponement in sight just because of our COVID situation right now. I think most of the systems are ready to go, and we have a targeted July launch date. So once the spacecraft launches, and then we are looking at around a 7-month cruise, as I said, from July to February. So it's going to take the shortest path that's available to Mars at that point. We're choosing July because Mars is an elliptical orbit, and the distance between Earth and Mars is closest between this time frame. So that's the reason we are launching in July. And then this cruise is now approximately 7 months, as opposed to longer when we launch it in a different date. So once we get to the atmosphere of Mars, then we are looking at the entry, descent, and landing criterion. You can see that's a retro rocket system with a sky crane mechanism, which is delivering the Perseverance rover down to the surface of Mars. And as you can see, this system has been tested over and over because Curiosity also had a typical system. So we are not reinventing the wheel here. We are pretty successful with Curiosity. So we're using the same kind of sky crane launching system for the Mars 2020 rover as well. It's been thoroughly tested so that the entire rover lands without any damage. So once we are in Mars with the rover, so the adaptability of the rover comes into play then for the Martian surfaces. So it has a 20-kilometer radius. It's qualified to operate for around 1.5 years, Martian years. It's slightly different to an Earth year. The main mission would be to seek the signs of life. What we're doing here, in addition to what we've done before, is we are trying to get samples from Mars and ship it to Earth again. So that is a significant improvement over other missions. So what we're going to do is we are going to utilize our best laboratories on Earth to do the work rather than the rover by itself. It's a laboratory granted, but its functionality is pretty limited due to size constraints. So that's really a game changer, and we'll get a lot more answers than the previous rover missions this time. So that's something that is unique to the 2020 mission. What are we looking at? Our mission objectives are are listed there. They're fourfold. So we are looking at geology, first of all. Uh, we are exploring the ancient environment on Mars. We are understanding the process of formation of rocks and other soil elements there, their formation and alteration. And the second goal is astrobiology, where we seek evidence for the past life. This is possibly carried out by carbon dating or say biosignatures that are preserved in the soil. How do you do that? Third objective ties to the first two. So we are going to sample it by actually drilling rocks or collecting soil samples using X-ray imaging that is built into the rover, or laser drilling systems that are there in the rover to collect samples and process and run certain tests within the rover itself. So what happens here is once these samples are collected and tested to one level here in the rover, these samples are archived so that it can be sent back to Earth in a different mission that's going to be carried forward in the future. So by doing all this, what we are doing, what we are answering is how fit the Martian environment is for the human life in the future. So we now know that we have a lot of carbon dioxide in the Martian atmosphere, but we don't have enough oxygen. So one of the things that the rover is doing is, one of the modules that is plugged in the rover is looking to do is like, it's trying to convert the carbon dioxide into oxygen. There's a module for it, which I will talk in the next slide. So typically these are the components in the rover. So most of them are looking at cameras, sensors, and other things like X-ray imaging systems. And there is also something called the MOXIE, which I was talking about here. MOXIE is the oxygen manufacturing unit within the Mars 2020 rover, so that there's some amount of oxygen that is required for combustion and other chemical reactions that are taking place within in the Martian surface. Like, to perform certain tests, you do need some oxygen. So that MOXIE module there actually gives you a laboratory method of preparing oxygen using the components that are available in Mars. So that's something we have to look at certain systems like that initially, because we don't have oxygen readily available in the Martian surface as of now. And there are a host of other sensors. There are infrared imaging sensors, temperature sensors, X-ray imaging sensors. You have several kind of radios to communicate things back to the Earth. Then you have other cameras all over. And you have the motion system as well. So it can traverse through any kind of surface. It can climb rocks, it can climb elevations easily. And there were tests that were carried on Earth to make sure that it doesn't get stuck anywhere in the process. In addition to this is basically carried on from the Curiosity profile. Curiosity was the previous rover. It's still working in Mars right now. In addition to the rover, there is a helicopter as well this time built into the rover. So this helicopter can actually take some aerial views. It has additional sensors, avionics in body. So it has a solar panel that provides energy to recharge its own batteries, and it can get some more information from a height rather than everything from the ground. So this is another thing that is unique to Mars 2020 mission. It's called Ingenuity, and it's integrated as a part of the rover itself. So this profile here is called the Jezero crater, and we are really interested in this site. The reason is because, like, you have a lot of evidence that there was some kind of river or water streams that were flowing at a given time. It's, of course, there's no water right now, but there's enough data there to tell that there was water at some point of time. So this would be a good place to actually land and look for biosignatures. So this is going to be the landing site. And for this very reason, this has been chosen as a landing site. So what are the science goals? Science goals, as we already discussed, is to determine whether life arose on Mars, how is the climate of Mars right now and how it has changed from before, and what is the characteristics of the geology on Mars to answer these questions. Also, the fourth one is the most meaningful of the three, and it doesn't mean that we can achieve four by not achieving one, two, three. So it's like a collaborated effort. Only if you can answer the first three can you actually answer the fourth one meaningfully. So I was talking about the sample return. This is not a part of the sample return is not a part of the 2020 mission itself, but what it can be done is like future missions can be allowed to land on Mars. So it can rendezvous with the orbiter there and then return the sample like through a rocket system separately in the future to Earth. So that gives us a lot more flexibility in determining the geology of Mars and life itself on Mars in the future. So this is basically my presentation in a nutshell. I'd not delve too much on things because like there may be specific questions in the Q&A session. But if you want to know anything more than what I've discussed here in detail, you have the NASA website, mars.nasa.gov/Mars2020. So this is my presentation in a nutshell. Also, I have one final slide talking about the other missions of NASA. So these NASA missions are centered around so many other things. Like if you consider the Sun, for example, there are these missions like the Solar Orbiter and AS and SET-1 that are, and Parker Solar Probe that is dealing with measuring several entities in the Sun. And then you have the Earth satellites as well, several Earth satellites. You also have the International Space Station where astronauts and scientists actually determine the characteristics of Earth from way above. And we have deep space. We have something to do with the galaxies, and that's a part of the mission that I was invited to. It's called the SOFIA mission, where you can actually determine the life cycle of stars, the ages of stars, and so on, using a 747 flight that flies high above the atmosphere, and then you have an infrared camera in the fuselage. So these are some of the exciting NASA missions, and we are not limited to space. We are also looking at aeronautics and aircrafts and aviation in general, how to streamline aviation, how to make aviation in the future more sustainable. So this is in a nutshell of what NASA is doing today.
Thank you so much. There's a lot of information there, and the graphics are amazing as well. It's a really interesting presentation. Sure. Are there any plans to send astronauts onto Mars in a future mission? When how many years do you think before NASA will consider?
So when they drafted the initial plan in 2012, so they planned a manned mission to Mars by around 2025. But I don't think we are going to hit that 2025 target the way we are going right now. We have to first achieve the Artemis mission. The Artemis mission is the first manned mission to Moon after all these ages. They're going to go and set up a base in the Moon, in the Earth's Moon. So that's going to be the next major challenge for NASA. They're preparing that as a part of even this SpaceX launch, where they're trying to send the astronauts outside the Earth atmosphere and let them acclimatize in the International Space Station first. And the next major step is going to be to set up a base in Mars. A base in the Moon, so that we can use that as an intermittent base to launch to Mars.
It'll be closer.
Yeah. So we have, in fact, Artemis program is running full scale now. NASA is recruiting new astronauts, and this mission is going to be the next manned mission to major manned mission that's going to happen in NASA. And we are going to. The idea is to use Moon as a base.
Okay. Oh, we'll look forward to it. That sounds interesting in itself. I think building a base and using that um, to do other projects will be amazing too. Is there any way Australians can watch the launch of this Mars mission? Would it be shown online?
Absolutely. I think NASA has its own dedicated channel. If you go to YouTube and search for NASA Live, you have a NASA Live channel that's presenting all their missions. Like on a given day, if there are no missions, they play all kind of informative programs. But then if there is a mission, for example, you can view the entire SpaceX launch mission next week on May the 27th using that NASA TV Live. So it's a brilliant resource, and I get to view it whenever I want more inputs for my presentation.
That's great. I've written it down, so I'll make sure I share that with our community later on. I think a lot of people will be interested.
Sure. The easiest way is to actually search it on YouTube, and you have this channel that's live all the time.
Great. Okay. Before today, I invited our community to ask any questions that they might have. They might be interested to ask you. And so I've collected a few questions that I hope you be happy to answer.
Sure.
Great. Okay. So I might start with one from me, because I would like to know a little bit more about the selection process for solar system ambassadors. What motivated you to apply, and was the selection process really hard? Were you like nervous, or did they make you do a lot to show that you have what it takes?
So this actually happened. I would say I'm extremely lucky that it happened in my case. So my passion for aerospace as a kid is a big motivation for me. So my passion for aviation and aerospace as a kid, I was largely influenced by my dad, whose job was involved around working with big jets for a leading Indian airline. He worked for Air India for a period of 30 years in ground handling. So I've seen these big jets close by whenever I used to accompany him to his work. So what happened is I'm an engineer. My day job is being a medical device design control engineer. I decided to I moved to the US in 2016, and I decided to actually take my passion to another level when I joined this organization called Civil Air Patrol. This is a US Air Force auxiliary, and it's also a volunteer organization, and it's a part of the US Air Force as a total force. What we do is, one of our pillars is aerospace education. So I'm an aerospace education officer for my squadron, and I have my colleagues are really helpful and knowledgeable. So some of them are NASA solar system ambassadors already. So I came to know through them about the NASA SSA program. And then last year in October, I went ahead and applied. The application process by itself, it was. I wouldn't say it was very complicated, but they were asking a lot of questions. They asked me to submit an essay on why I wanted to actually become a solar system ambassador and what was unique in me, and also my presentation abilities and my other works that I've done in the past. So Civil Air Patrol was a big boost for me there, because I was already handling aerospace education for my squadron back then. So, and probably that is one of the reasons why I was selected. But at hindsight, I'm privileged, because there are only thousand such people around nationwide in the US. So to know that I'm among them is really nice to know, and I'm grateful too.
And I think it's wonderful that you can take your passion, something that you've had since you were a child, and grow it into something that gives you such amazing opportunities.
Absolutely. I mean, life is not just about a day job and making money and living on a paycheck. So it's something beyond that. You have to, I believe that you have to share whatever you know with the community, and then motivate other people forward. So, I mean, although I didn't get to become an astronaut, if someone becomes an astronaut through my words, I mean, listening to that and getting inspired by that, I mean, I'd be the most happiest person.
And you mentioned that you have met a few astronauts as part of your induction to the ambassador role. Have you also been on the NASA sites?
I have been on the Ames site. As I told you, I was there for the Sophia mission. Let me show you a photograph.
Mm.
Yeah. So I think I have to share the screen here.
I think that will work best.
Yeah. I'm going to share an image right now. There you go. So this was at NASA Ames. Again, this was through Civil Air Patrol. Civil Air Patrol gave me lots of opportunities to interact with the NASA guys as well. Just it's not the SSA program, but I'm happy that I can show you this because like I get to meet people like the person here who's in charge of the Sophia mission, and the other people in the squadron are present as well, and we try to present this in our squadron, take the learnings from here and present it.
And I think it'll be so much fun just to meet with other people who are passionate about the same topics as you, and you can have really deep conversations.
So, the questions were really focused, and he was pretty open to answer them as well. So that was pretty nice.
That's great.
This was the Sophia mission I was talking about. This aircraft behind me there hosts a telescope. It has an infrared telescope.
Oh wow!
It takes pictures of the night sky, and and we can determine the several celestial phenomena, like years of stars and so on.
So you use it while the aircraft is airborne to get just a bit closer.
That's correct. So the mission itself, talking about the Sophia mission, the aircraft travels around from California to New Zealand, Christchurch in New Zealand. That's where the path is, so that they can, in the night sky, they can get most of the images of the stars. And so.
That's great. Okay. Okay. Now here, thank you for answering my question in such detail. Sure. Here's another one from Olivia. She's asked, when can we go and live on Mars?
I've answered this question partially in my presentation. It all depends on what kind of questions we are able to answer on the samples that we get from Mars 2020 mission. As I said, we are going to get a lot of samples back to Earth. We're going to analyze what best we can do to live on Mars. One thing is certain, we are moving closer and closer to living on Mars. So the data we have collected so far is leading us in that direction. It's the question of when rather than if we go or not. It will surely do. But depending on the data that we collect in these rover missions, we have to determine the kind of life support systems that are required for us to survive on Mars. So it's like, even if you are going to Mars and live on Mars, it's like to develop a colony in Mars, it's going to take a while. You will see a lot of manned missions to Mars, and then developing a colony there, an ecosystem within the planet surface itself, where we can grow plants and have water and oxygen. Basically create an artificial atmosphere for us to survive initially before we can spread life form in the future. So definitely it is on. It's just a question of when and how we are going to approach it based on the data we gather from the samples that are going to come.
I know that the film The Martian has been on Australian television recently. And I mean, I understand that the science depicted in it is not always perfect, but it makes it so real and almost possible. It really stretches your imagination about whether it's possible to go there and so on. It's amazing.
Absolutely. I think that movie is a bit ahead of our times, and I think it's wonderfully taken as well. I wouldn't say like what you see on screen is exactly how it will be, but it will be pretty close to that.
Yeah, I have heard that it's been praised for a relatively sort of accurate portrayal of the science and the physics.
Right. Right. So they also say it's pretty accurate. They also say a term called sol, which is the time on Mars. It's slightly different to the time on Earth. Like it's not exactly 24 hours. It's slightly greater than 24 hours, if I'm correct. So they call one sol one Martian day.
Great. Okay, I've got here is a question from Michael. So Michael says he doesn't have a STEM, a science and technology background, but he would still like to contribute to NASA missions. Can you offer any advice for someone who might be more interested in the legislative or legislative affairs side of aerospace exploration and of NASA?
So something I wanted to tell Michael is this is a very good question, and NASA is such a huge organization, and we require all kind of people here, be it in areas of science, artists, graphic artists, business managers, IT people, technical writers, programmers, all kind of people. The same thing goes with legislations as well. What I would say is legislation. The role is pretty important because we have several R&D projects in NASA, and we have several legislations and budgets that are surrounding each project, whether a particular task should go on as per planned or it should be tweaked. So these legislations are normally passed by Congress in the US. So his role there would be like a perfect fit, I guess.
And I guess also the more space exploration we achieve, it creates new areas of law that we need to tackle as well. For example,
That's
it's
absolutely
bit like exploring Antarctica, where it sort of doesn't really belong to anyone, but you need to create some rules about what's allowed and what's not allowed.
Right. Right. One of the parameters, I am glad you brought this up, because one of the parameters that we are concerned about right now is space debris or space junk. These satellites that are no longer functional are left in the orbit, and then these remain circulating the Earth for no reason, and they have no purpose. So how do you get them out? So that's one of the legislations that are going on right now. There's a separate body for it right now.
It's funny that you mentioned space junk, because yesterday I led a children's coding event called Moonhack, where people who participated created a game in Scratch, which is a coding language devised by MIT for teaching children to code. And the topic is space junk. So it was a little game where the player pilots a rocket, and it gathers various types of space junk and try to send it to Earth. So definitely, I think it's getting to be quite a big issue, because we've had many decades of space exploration and sending things like satellites up into space. So I think I've heard it's all definitely accumulating and becoming a bit of a danger in some ways.
Right, it is of danger, because these space junk may hit other active satellites, or maybe even the International Space Station when an astronaut is working on something. So these can actually penetrate and create big damage. So it's imperative that we remove this space junk as soon as possible, or put it in an orbit where no one goes.
All right. Thanks for that. Now, here's a question from Roman, who says he's learning about the sun at school. He's trying to, he's preparing a project about it. And he's asked, can you tell him any exciting information about the sun? And perhaps where he can find more information.
Right. I would give a few points. Of course, he might already know this, but if he doesn't, then it's a new piece of information for him. So I would say sun is basically the largest object in our solar system. It takes up 99.86% of the solar system by mass. So that's about 1 million Earths. If you can fit 1 million Earths into the sun's surface. That's one interesting fact. The other interesting fact is, given the size of the sun, it's not the largest star around. It's just an average star. So even for an average star, you would know that the size of the star is enormous. So
that's an interesting fact, because I think when we visualize the solar system, you assume there's a lot of space around. So you sort of don't think of the sun as, being a really big part of the solar system.
That's right. Our solar system is kind of so big in terms of size, so that's the reason we don't associate. But if you see, if you compare the sizes and the masses, any star will comfortably outweigh a planet. It doesn't matter even if the planet is Jupiter or something bigger than that, or an exoplanet.
Okay, I hope Roman finds that interesting just as I did. Here's a question from Emma. So, what do I need to do to become an astronaut, and can Australians be astronauts?
I would say with the tie-up between NASA and the Australian Space Agency that happened in 2018, I think there is a good chance for Australian citizens to actually work with NASA and participate in NASA missions either as an astronaut or any other entity. I mean, any other role. So NASA has a tie-up with the Australian Space Agency and the Commonwealth Scientific Industrial Research Organization, which is
CSIRO. Yep.
Yeah. So before this tie-up was there, like there were plenty of Australians who were there in the NASA workforce, but they had to change their citizenship to the US to actually get into NASA. So that's no longer the case. So that's the good news. If you go through the Australian Space Agency, then that would be a shorter route. One of the things your PM Scott Morrison did in 2018 was contribute a lot of revenue towards the Mars mission. So NASA is really working hand in hand with the Australians. So that's good news for the for Australians to become to play significant roles in NASA in the future, not just astronauts, but. Yeah.
I think that's really encouraging news, that to know that we've got more opportunities now than we did.
Right.
That's great. Okay, and one final question from Jackson. Do you have this is a question for you. Do you have a favorite fact about space, and do you have a favorite fact about NASA?
Okay, my favorite fact about space is we cannot really measure space. Space is so huge. Even if you take our own galaxy, the Milky Way, we are talking about 100 to 4 billion stars. So when we're talking about 100 to 4 billion stars, we are even talking about parallel solar systems, parallel universes that can exist and support life. So it is impossible for us right now to actually determine this with the level of detail we have right now. But in the future, I think as we gather more and more data, we will see that other life forms as well in the future. I hope in other solar systems or other parts of the galaxy.
Mm-hmm.
So that's an interesting fact about space. And the next one was my favorite fact about NASA. My favorite fact about NASA is so many things. It is just not like confined to space, as I told you in my presentation. So we talk about earth sciences. We talk about helping the farmers to irrigate their crops with the right amount of water, depending on the satellite images we get from the satellite systems and International Space Station observations. One of the projects that I liked so much was the population of mosquitoes in certain areas of the world at a given season, and how we can manage the mosquito population so that we can control malaria in different parts of the world. And the other areas of NASA I highlighted was the aeronautics. The aeronautics basically deals with improving the efficiency and sustainability of aviation and general aviation aircrafts and supersonic aircrafts in the future. So how best we can control noise and pollution, and how green can we get. Electric flight, for example, is something that NASA is working on right now as well.
That is a really interesting fact. I think when most of us think about NASA, we just think of space. So it's interesting to know that there's more other areas of research that they do at a more ground level.
Yeah, we call it the A in NASA. So NASA, the second A stands for aeronautics. So that's something NASA is pretty good at. And a lot of people are not aware of this.
That's great. Well, thank you so much for the opportunity to connect with NASA and connect with you again. It's been
Thanks,
a
Karen.
real pleasure and so exciting.
Thank
And
you. Thank you.
I hope that one day you'll make it to Melbourne. As my community might not know, but Kailash is a big cricket fan, and I think he'd love to come to the MCG one day for the Boxing Day test. So, we would love to welcome you if you ever make it out to Melbourne.
Absolutely, absolutely. Thank you so much. I'm looking forward to that date, and if that opportunity presents itself, definitely. I mean, I'll try to make this happen someday. Thank you so much.
Thank you so much.